people. Don was one of the original founders with three other directors at the time, who spun out from Leica Microsystems in Cambridge, and basically saw the need for automation control, the ability to be able to manipulate X, Y, Z access, and also integrate it into systems, image analysis systems, etc., where there was a real lack of understanding between the software and the hardware control. So what we were able to do as a company is to produce very fast and efficient controllers that were able to really integrate well with imaging software. So we've probably, through our control boards, sold close to 10,000 systems over the years that have been integrated into Leica's systems and others who have used the technology. And then over the years, we decided that we would not only make controllers, that we'd start to make our own stage. It was a kind of logical progression. So we made our own stage and were able to control that. We then decided to make our own scanner, and about six and a half years ago now or so, we made our first digital pathology scanner, which was the Glissando 2-slide scanner, which is the smaller brother of this scanner that we have on show. The scanner was very successful, but it only has 2 slides. Its ability to give very high quality output images has made it the scanner of choice for a number of prestigious institutes and organizations. People like WHO in Lyon actually selected our scanner from trials of many because of the high image quality to produce their reference slides for cancer, for oncology work. So it's a prestigious account for us in terms of their ability to produce high quality images, and the need for that for people to be able to understand what they're looking at. We're also in places like Sana, we're also in Munich, in Karolinska, in some places in America as well. So prestigious clinics that, again, have done complete evaluations of scanners out there and chosen ours for image quality. So having established a good quality scanner, the next question people said to us, well, this is fantastic, but it's still only 2 slides. And, you know, can we have more volume? So we basically designed a version of the scanner which uses the exact same stage optics. So we haven't messed with that at all. And then we created a loader module that goes on the front of the original scanner to create the 20-slide scanner that you see here. So we have in here a number of slide bays into which we put our slide holders. We'll go in and Reese will demonstrate this to you in a minute. But we have 10 of these. They can take, the format is either 2 single slides or 1 main. So we are unusual in that not many scanners on the market actually can cope with a mega slide format. So we have that interchangeable. You can mix and match. You can put mega slides and standard slides on this scanner. It's not a problem. The slides go in the clip and are held, so I can turn this upside down. Unlike other slide holders that might just drop out, this one actually retain. There's some little magnets on the back here, which just when it goes in, locate it crisply into place and hold it in the right place in the loader, ready for loading onto the scanner. So other products that I should mention that are complementary to this, which may be of interest, is that we've also developed a system called Image Share. And Image Share, the hardware to this is shown just here. It's a 60 terabyte storage RAID array, which basically holds all of these scans, so you can hold tens of thousands of scans on record on this device. But with the software package that we have with it, it allows people to share those images very easily. And in fact, I'd sent through to Anton and the team a link that demonstrates exactly how this works. So you could scan in one location in your number one lab and decide that you want to share those images with colleagues all over the world if you wished. And you basically, the software will send out a link, just like the link I sent you. When you click on the link on the left-hand side, you see all of the image files. When you click on any one of those, it expands up. You can drag it and move around to inspect. You can also enlarge the image through a scroll function. So it gives a great way of sharing digital images without having to send or have very high-speed internet access. Because if you're trying to, some of these images are 2.5 gigabytes, it'd take a long time to transfer on the internet. With this system, all you're doing is accessing a secure link back into the image share device. So in fact, the image share we have running in our office in Cambridge is where those images are hosted. And all you're doing is coming in and having a window, a view of those specific images. So they're a great way of sharing those images, so that, you know, you could be sitting on a beach somewhere looking at the image on your phone or an iPad. You know, it's as simple as that. So it's an important way for people who are getting into digital pathology as a step towards, you know, full switch over to digital pathology. You can use this as a stepping stone. The other thing I should mention is all of our scanners, whether it's the 2-slide, the 20SL, or the polarized light scanner, they're all fully integratable. Our output files are SBS, and they integrate with existing IMS systems from companies like Leica and Philips and Sectra. So wherever you have an SBS file output being acceptable to IMS, we should be compatible with those systems. So Don, hopefully I've covered most of the areas I think that we were interested in, unless there's other things to add on.
Yes, beautifully. I think the idea there is to allow you to select a digital pathology environment that matches your needs, budgets, and so forth. So we make the scanners, obviously, and we have our own basic image sharing capabilities, which is very effective for storing images and doing basic sharing. But we also have a lot of experience working with third-party IMS vendors, as Adrian says, Sectra, Leica, Philips. We've done work with all of these companies, so that if you have more sophisticated needs, then, or existing labs that have one of these other scanners, like a Leica GT450, and you need to have medium capacity, we deal with all these different types of integrations. So there's a strong emphasis in our company with compatibility and what's called interoperability, the ability for our products, our scanners, to integrate seamlessly with whatever level of image sharing and archiving system you need. Exactly as you've said, Adrian.
And I think there's only one other thing to mention, which is, you know, coming soon, which we're going to be launching at the Digital Pathology Show in London, is the XL Plus product. And what that is basically you take a series of Glissando 20SL scanners, so maybe let's say 3, you link them together with a central brain, and a central monitor. So you only have one monitor, not three. And now you can run 20 times 3 in parallel. So you could be analyzing 60 samples an hour, for example, and then just cycle those through. So it gives the customer a chance to add machines if their volumes start to increase over time without having to go out and buy a very expensive large volume scanner. It gives flexibility and the ability to add on. So each of these scanners, we should have said, has an onboard computer. So they are completely standalone. If we link them together, whilst they have a central brain, if one of the scanners had a problem, you'd still be scanning on the others. So there's built-in redundancy to the XL Plus concept that allows you to successfully scale your volumes and add on a cost-effective platform and solution that 3 of these scanners would fit in 1 meter of bench space. So that's coming later down the line. We're going to be launching it at the London show, as I said, in December, beginning of December. But I wanted you to understand that you can scale our solution to actually achieve quite significant volumes of, say, 60 plus scans an hour. Would give quite a high volume throughput and flexibility. So probably, unless there are any questions at this point, perhaps we can demonstrate the scanner working. We'll switch it to TeamViewer in a second to show you the screen running, and you'll actually see the steps that you go through to conduct a scan, and you can watch it as it creates the scan images. The scan images will be identical to the images we sent you on the image share. They're effectively the same quality, etc. So at this point, I'm gonna hand over to Reese, and then we can come back after the demonstration and maybe answer some of your other questions if we haven't covered it. So I'll ask Reese to step in and do the demo, and then we'll transfer in a few seconds. Okay.
I think we can start demonstration.
Great. So Reese, what we want to see first is basically just how we load the slides into the scanner. And then once we get them loaded, we'll switch to, I think, the screen sharing part of Teams so everybody can just look at the way the software handles the slides and we get the scans done. Okay?
Yeah. So as Adrian said, we've got single slide in the slide holders. So it just goes into the cassette here. We're going to do 2 slides for the sake of this demo. And then you just close the door and then start using the scanning application.
So we switched to TeamViewer now. Please just pause a second.
Is that panel's handling that bit of technology? Look at that. Amazing.
Yeah, there you go. So hopefully you can all see that.
Yeah.
Yes, we can see.
Great.
This is our scanning application. As Adrian said, you've got the option to do mega slides or 2 single slides, or if you wish, just single slides. We've got 2 single upper slides. Also got different sample setting options, like I said, stack. But it's very simple. You just choose which option you want and click scan. It's now going off and detecting how many slide holders you've got in place. So as you can see, it's detected there's only 2 slide holders. It's now loading one of those slide holders and acquiring a preview image. So as you can see, it's automatically put on your autofocus points. You can then manipulate the size of the scan. So for the sake of this scan, we'll do a smaller area.
You don't have to do this. You can actually leave it as what it's detected and run. But just for the sake of the demo, we've selected an area. The red dots you see are the predicted focus points that the system has already selected, but you can change or add to those if you wish.
Yeah, so if you wanted, you can add more points or remove points. It's also read the QR code and named the slide. So that's it. So then you can just add to queue and click next. And behind the scenes, it's gone and loaded the second slide. So we'll again just use a portion of this. And again, it's named it, and we'll add to queue. So this is.
So we're now scanning. So what's happening here is we have a system that's loading preview images of the slides so that you can verify and adjust, if necessary, the regions on each slide to scan. This makes the 20SL scanner very flexible. In fact, some companies use our scanner to handle the slides that their main scanners cannot scan successfully. So even though we have automatic tissue detection and automatic focus point selection, we do have a workflow that allows you to quickly review each preview of the slide to make sure that you're going to get the result that you want. And this makes this 20SL scanner very effective in giving good scans on really any type of sample, even slides that may have a cover slip issue, a label issue, weak stains, very difficult slides to scan. Our scanners can handle them. During the preview phase, if we had loaded 10 holders with 20 slides, whilst we were previewing some of the images, once it's got the preview images from all the holders in the scanner, it will begin scanning in the background. So it's actually doing two jobs at the same time. Whilst you're reviewing maybe slots 7, 8, 9, 10, it's already scanning what you've previously reviewed in slot 1. And when the XL Plus scanner concept comes online, multiple of these running in parallel, then that becomes even more efficient because you're getting previews from all scanners into the workflow, and each of those systems can be scanning in parallel while it's going. So this is a very efficient but flexible workflow that helps guarantee that you get good results from your scans. So it's finished the first slide in the first holder, as you've seen there. So it shows you the scan being made. That's now sitting on the disk somewhere as an SVS file. And then the next holder is being loaded, and it will begin scanning the next slide shortly as it begins focusing the focus map points and then doing the final scan. Okay, so this is essentially the workflow of the 20SL scanner. Any questions coming from this phase?
As I understand, it is two possible workflows. We can, for example, automatically put all 20 slides and not have manual selection of areas, or we should select manually every slide.
So this system has what's called CE-IVD clinical validation. The clinical validation includes the review stage, so that is built into the workflow. However, if slides are well stained, the tissue detection will automatically detect them. And so it's just simply a matter of a very quick review of, yes, this one's fine. So you spend a couple of minutes just going through the review phase, and then it's off scanning. So we've left that in because of the IVD certification included that step. And so we're reluctant to remove it because of that would invalidate the clinical validation, which is important in many areas. So you do have to go through this phase, but it can be quite quick because if you don't have to do any adjustments.
If everything fine, we have only
one click, yes.
One tissue slide on per slide, so we can just click scan.
That's right. That's right.
Yeah. That's correct, and the whole process of doing the review and to scan of a complete fully loaded is probably around about 4 minutes, if that, and then you walk away, but you're going to get 100% success with your scans. That's the big difference to the high volume scanners where they have a number of rejections because they're not able to cope with differences in field depth. And because we can pre-select that and make sure it's okay, we don't get the rejections. In fact, all the Philips Leica and all these other systems use our scanner to sort out all the slides they can't scan for that very reason.
So as I see these slides, one slide, 2 minutes. This scanning speed. Like one.
Yes, for the areas that we selected.
Your scanner is 40 or 20.
40x.
40x.
Yes.
40. So if 20, it will be around 2 times faster. Okay.
Correct. Yeah.
Correct. So. You're correct. Yes. That's the highest quality images. And so in general, we are using the 40x for those cases. There are some special applications such as frozen section review, where the 20x is acceptable. We do not have an IVD for that use case, although we are close to starting one. So we are considering that use case, but for the formalin fixed paraffin embedded specimens like we have here for normal diagnostic use, we are using the 40x, which gives roughly 0.26 microns per pixel in the final result. So that's the resolution coming out of the 40x whole slide images.
So you have IVD certification for 40,
yes.
And 20 is research use only.
Correct.
Okay. So what about next steps with storage and sharing these slides, or maybe annotation? What can we do next with these slides?
So the next phase for the slides depends on the integration that you do. So in the image share case, our own archiving system, these slides are being scanned into an SVS format. They get copied into a folder. So the image share is a large storage that is organized into folders. So you create as many folders as you want using normal Windows type of functions. And then the scans can be copied. And we have a utility on the scanner where it takes the images and automatically puts them in the folder that you've decided to run for that day or that case. And then the image share itself allows you to drop in folders from the image share into a special application that runs on the image share, and that creates the internet link. That's what creates a browser link for that folder, and then that link can be copied and shared. Right, so it's a very simple solution, but it's also very simple to implement because all we need is a basic internet connection, and you can send those links via email, as we did, as we did earlier, Anton. We shared that with you, Anton, and I guess you might have passed that on to everyone. So that's a special link, you can open it in basically any web browser and then see the images in that folder on the image share. And the image share software is like a web server or a cloud storage web server, so that your browser will be able to zoom and pan the images on the image share without uploading them to the cloud or downloading them or anything. That's the power of this solution, is that we create a special browser link. The images stay locally on your image share, but they can be viewed through the internet in any way. This reduces the demand on your internet connection, because each of these images can be hundreds of megabytes up to several gigabytes. And so you don't have to load 2 gigabytes with every scan up to some server. They just get copied locally onto the server. And as long as the image share has a basic internet connection, the viewer will work anywhere. And that's what's next for us. So and that's just automatic. It just gets copied onto the image share, the folder gets shared, and then you've seen the result. I mean, that viewer is the viewer. It's exactly what you would see. However, you may have more sophisticated needs, and you could find a digital pathology solution from a third party that has things like case management and user access control and more sophisticated types of digital pathology tests. And so our images are also supported by that. We have many systems out there connected, for example, to the Philips IMS, to Sectra, and so forth. Fujifilm's, the Inspirata, for instance. Also solutions like Easy Zoom, objective pathology. There's many different third parties we've worked with, and it really just depends on what you need. If you need something beyond what our image share can do, in terms of its case management, for example, then you can choose another third party and we can easily work with them. We probably already have worked with them. So our solution is basic, but it's also very simple to get running. You buy the image share, you plug the internet into it, and it works. It really is as simple as that. There is a yearly fee that covers the cost of keeping the URL server going. So we have a special, but it's not like a monthly fee. It's not based on the amount of data. It's just to keep the server that does the URL management running. Other than that, it's all bought into the image management system itself, the RAID array. And we have things like redundancy in the array. So if one drive fails, you don't lose your data. You can just swap out for a new drive and keep going. So we have all those basic security and redundancy built into the image share. What we don't have is the same digital pathology as, say, a Philips IMS or Sectra. But of course, there's a big difference in cost there too, right? But you can choose, which might work for you.
Mm-hmm. Mm-hmm. So I understand that your product is just scanning and sharing, and if we want to have more functions like annotations of some, choose some points of this slide and
Yes.
to show another pathologist what we are interested for in this case. So we can combine with other solutions for such proposals. Okay. Mm-hmm.
That's right. We also have compatibility with image analysis and artificial intelligence systems.
Mm-hmm.
So image like Visiopharm, for example, is one that's out there. We know our scans work with Visiopharm. There are AI companies like Ibex and many others that Iaphoria and so on and so forth, who all will understand the SVS images, and we've already done work with them. So the core message, I think, that we can deliver today is that we have very good low and medium capacity scanners that produce excellent image quality. So our scanners give you that combination of automation, flexibility, and really as good at image quality as any scanner, honestly. So you're not sacrificing on the quality of the image. It's just capacity mainly, and some degree of the automation that you might see in the high throughput scanners, but we're not trying to compete against those. We're trying to, serve this medium capacity market.
Currently, we don't need high capacity. We are interested in medium capacities. That is why we are here now.
And our focus on image quality, you probably understand, because it's pointless having a good scanner or a fast scanner if the images aren't actually coming out in focus. So it's very important to focus on the image quality side of it, which is our #1 priority in these scanners, but also a very simple yet flexible workflow. And as I say, the compatibility to make sure that if you choose our scanner, you know that we've worked with many different companies, so you have lots of options depending on what you exactly need on the other side.
All scanning companies are now like an open system, because because no way, no another way.
That's they have to be. That's a big drive, I think, in this market. And along those lines, we are close to releasing DICOM outputs. So that's one topic about compatibility, is who's got DICOM support. We're one of the companies that participated in the DICOM test that was part of the Budapest meeting earlier this year. That was successful. So we're also quite far along on our work with DICOM. That further enhances compatibility and interoperability for the future. So we're part of the ones leading the way on that effort too.
Okay, and maybe just to show for my colleagues also, what actions do we need to do to create link, as we know?
Right.
As we
so let's see if we can figure this out. So let's see. I might be able to do it from here if I TeamViewer into the image share. Let me see if I can set this up.
I mean, once it's set up, all it will do is you name the folders and create the folders, and the images that you scan will automatically go into that folder and be available for anyone to see. So if we'd have added those scanned images to the ones we sent you earlier, if you refresh that, it would have seen those images as they're coming through. You would actually have almost immediate access to them.
Just give me one moment. See what I can do here. Yeah.
So while you're doing that, Don, we can just have a look at our local viewer to just have a look at the images that we just scanned. So you can either scroll in with the mouse wheel or choose which magnification you want to go to straight away. So this is a 40. So then you can pan around or click the preview to quickly move around the scan.
Yeah. Essentially, yes. The ability to be able to, do that.
Good quality.
This is another area where, sorry.
I just asked they answered that only scanning and sharing, but compatible with other solutions for additional tools like annotation and measuring and so on.
Correct. So if it was linked to a Leica or a Philips or their IMS, you'd be able to use their system to annotate, etc. SVS SVS, which is an industry standard format. We have our own version, which is SWS, but that's not compatible with other people's systems, whereas SVS is an industry-wide standard format.
Another area where being able to manipulate the focus points is helpful is when you've got things like folds in the tissue. If it happened to put a point on there, then you can remove it. We've heard of
and
that's a problem.
Certainly, this kind of slide that we've got here with this area where you've got folding is a classic problem for some of the big scanners on auto tissue detection, because if it picks anything here, it throws the whole image out. So typically they end up with a non-focused image that's rejected. And that's the beauty of our system, where we can cope with these kind of samples and these kind of anomalies and not a problem. And we can solve that problem. So this is a classic example of something that might get rejected on a large scale scanner that we can 100% detect, like you've just seen, and seen the quality of the rest of the image is not affected by those anomalies.
Mm-hmm. How can we convert the slide into the link? Communicate maybe, or actions? If you want to sense what we need to do.
If we'd have set this up, then we could have scanned into an image share folder. And I guess we could have scanned into the one we've got, and then you would have seen it appear at the end of the list on the link. So if we had image share set up on this particular, because of the short notice of the demo, we hadn't really set up the image share on this scan.
Okay. I understand. No problem.
I'm going to try. Yeah, I'm going to try to do this. Hold on. So I've got to just bear with me for 1 minute, and we might be able to show this. Just give me a second.
But just to explain, it would be easy if this was set up and we'd already linked it to the image share. As you're saving the files, it would go into an image share folder, and it would be immediately available on the folder. We actually demonstrated this in Vienna in Austria, where they had multiple hospitals, and we literally used the image share with a 5G router and basically shared the image to 4 sites simultaneously, and they were actually watching the images come in live into the image share. So once it's set up, it's easy. It's just literally we didn't have much notice with this demo, so we've only just managed to get a scanner ready to demonstrate this. But
yes,
maybe Don will find a back door.
It's not a very important point. I just asked it because to have a full picture. But if I understand that you have not this program on this computer, so no problem.
Yeah, correct.
As for me, I have not any questions. Everything clear and scans very good quality. Everything clear about functionality of this scanner and your software.
Great.
Maybe I have this link. I will find.
Yeah. Correct. Yeah. That's correct. And then if you want to share that link, so the link is created, you then just can email that to as many colleagues as you'd like. And they will be able to see exactly what you put in that folder.
Yeah, yes, I understand.
Yeah.
Just a link for all people who have this link. I understand.
Correct. Yeah. So if you tried that link, were you able to try the link and access the images?
I just can't find this link that Anton sent me.
I sent it. It was embedded in the email, I think, but
I can send it by the chat.
you can put it on the chat, Don. Yeah, that'd be great.
There you go.
Oh, okay.
So it's on the chat. Yeah.
This it is a full folder with
yes,
with different scans. Okay. One more question. When we scan, can we edit the name of this scan? How can we identify which scan is of which patient?
They will come with its full barcode preview as well, so you'll see that on the left-hand side. And then you click on the image you want to look at, and it'll expand up. But it's got the preview image of the whole slide.
I see this this information, but my question is, we put this information before scanning the slides or when? How we identify slides when we scanning?
So when you first put the slide in the scanner, it will capture the whole slide image and label, and give it a unique name at that point.
From the barcode.
From the barcode, so it's using the barcode.
For example, in Ukraine, we often have slides, for example, from other government hospitals without barcodes.
Yes. So you can enter this information during the preview part of the scan, so that you can just type it in. it will create an automatic file name by date and time, but during the preview, it shows you the name that it's giving it, and you could just change it to whatever you want at that point.
Okay.
Okay. So if there are no barcodes, you have the ability during scanning to just change the name there. The label images are incorporated into the SVS, so you'll see the label. So if there's a patient name or something but no barcode, if there's just writing but no barcode on the label, you'll still see the label as part of the image share.
Okay, I understand.
And good news, I've got the image share connection running. So I can show you that right now if you're interested. I just share my screen.
Okay. Yes, and link also works. So
Okay. So this is an image share that I've gotten connected to. And it's got some images in it. And so I've just got a folder called demo. It's got some scans in it, but I think maybe just a few of them are compatible with the image share. It's got more than just that type of SVS. But all I do, I'll show this from the very beginning. So there, on the image share system, there's a piece of software called image share. And we run it up, and it looks like this. And it has a set of links, but what will happen is I can just drag the folder on the image share onto the image share folder, and it will create the link. That's all there is to it. And so now we have this link that if we click it, it copies it to the clipboard, and I might be able to send this to you. Let's just see if this works. It'd be quite amazing if I had that link, but let's see, because this is on a different computer. But demo 1 US, I think that's it. So I've sent you a link. So let's see if we can get through this link.
Yes, I just opening this link.
And
yes,
there they are.
Okay. Yes, I see the slides. Okay.
So these are frozen section slides, actually. And sub-tissues. So this is obviously not frozen section. So that is the way the image share works. It's very, very simple. It's just dropping, and so you create on your image whatever folders you need. One example I'll give you. We have been working with Mount Sinai Hospital in New York City in the United States with a surgical center that they had established in Uganda. And this is in a remote part of Uganda, and they've created a surgical center for the people of Uganda. This is Mount Sinai Hospital in New York, where they can do telemedicine. So the surgeons in New York use this special technology from Microsoft to help them decide where to cut and everything. And then we've worked with Mount Sinai to put one of our glissando scanners at the site in Uganda with an image share just like this, where they're getting images, and they've got a workflow where they just establishes folders for the cases that they're running each day. And then those image share links are sent to a pathologist in New York City at Mount Sinai Hospital. And there's a pathologist at Mount Sinai in New York using an image share like this to do the daily diagnostics for the patients in Uganda. And this type of technology shows how that can work because, the scans just stay in Uganda, and they have a basic backup system using external drives if they needed to offload the images from that image share, although it's got a lot of storage. And the pathologist in New York just looks at the links he's been sent, goes in, sends them emails back with the diagnostic data. It's a very simple, very easy implementation of full digital pathology there at a very remote site. And it works in this way, just as I've shown you. So it really literally is as simple as that. You drop a folder full of scans
very
into
fast.
the image share.
Okay.
And that was live, so I created the links to the image share as you saw, and then put them in the chat here, and you're looking at them now. So that is how this works. That's how an image share system is implemented. Again, it's very simple, but it's also very easy to get going with digital pathology with a glissando scanner and an image share.
Great. So